So for our example number 4, this problem is similar to that of example number 3, except that the bulb does not swing left and right, but the bulb is revolving about an axis, about a vertical axis. They are just similar, but they are not the same. So we need to study this type of a pendulum, a revolving pendulum. So the problem reads, the ball has a mass m and it is attached to the cord which has a length L. The cord is tied at the top to a swivel and the ball is given a velocity v sub naught. Show that the angle theta which the cord makes with the vertical as the ball travels around the circular path must satisfy the equation, which is tangent theta sine theta is equals to v naught squared divided by GL. The assumption is that neglect the effect of air resistance and, of course, the size or dimension of the ball. Okay, so the problem is we need to show that the theta, the angle theta, satisfies the equation shown. Okay, so again, let's I think there are no other givens except for the FBD diagram. You just need to show the FBD. Okay, I think I just need to write the FBD here on the space diagram. So first, of course, our object is rotating. The cord is tied at the top of the swivel and the ball is given a velocity v naught. Okay, so let's show the forces that act on the ball. Of course, first we have a weight, and then we have, of course, the tension. So let's draw the normal tangential axis. Of course, the normal axis is here. The tangential rather. Then the normal axis is right here. This is the instantaneous center. That is the N. Okay, and of course this is the binormal. There are no other forces because air resistance is neglected. So in this case, it is not the weight that has to be resolved, but the tension. Okay, because we have the right axis that we are going to use, which is the NT or the path coordinates. It just happens that in this kind of problem, the tension is the force that we need to be resolved. So as you can see, if we have a tension right here, the component, that would be Tn, and right here, that would be, let's say, Tb. So Tb is paired with W, the weight, and Tn has no pair, and that would be okay because Tn is a centripetal force, and the pair of the centripetal force is the centrifugal force. And as I've mentioned before, centrifugal force is a fictitious force. It is only a consequence of the law of the third law of Newton. And Tn is responsible only for the change in direction. The ball does not come towards the center, but being changed constantly. But its direction is being changed constantly by the centripetal force, which is the Tn. So this free body diagram is the correct free body diagram. So I guess we need to go for our next step, which is the equations of motion. Take note that the ball is having a constant or initial velocity rather, which is v sub naught, and v sub naught is constant, And that is a very good assumption because there are no other forces that act along the tangential axis. And remember that for a motion to have a constant, for a body to have a constant motion, it does not require any force at all. The effect of the force is only to change its course or to change its magnitude. But for a straight line or circular but for a straight constant motion, there is no force involved. Of course, there is in type of force that is involved here for the particle, but it does not change the magnitude. It changes the direction, and that is the Tn. Okay, it does not change the magnitude of V0, but its direction. I hope we're clear with that. Okay, so now we're ready to. The required is of course to show. So the solution is first we need to summation of forces along the binormal. That would be 0 because it is being balanced by the tension. So that would be Tb is equals to weight, which is of course T, and our angle is here. That would be cosine. T cosine theta is equals to mg. Okay. So next, we need to go for the sum of forces along the normal, which is of course MAN. And what are the forces? It's just Tn. Tn is equals to m, and the formula for normal acceleration, that will be v squared divided by rho, the radius of curvature. So our Tn, that would be sine of the tension, of course V0 squared, and our radius of curvature is equal to cosine sine L. That would be sine, that would be L sine theta, correct? L times sine theta is equals to the radius of curvature. Okay, so we have a tension. We can eliminate tension. Here the tension is equals to mg cosine theta. We can substitute this one to eliminate tension. So that would be mg sine cosine theta is equals to m v0 squared divided by L sine theta. So this would result to tangent. Cancel m. So that would be tangent theta g is equals to v0 squared L sine theta. So finally, our expression for angle is tangent theta, then sine theta is equals to v0 squared divided by gl. Okay, so we have proved that expression.